Becky and John are with us tonight. They're our Python experts. Becky is a nationally board certified teacher who teaches grades 9 through 12. Her current classes at Kelly Walsh High School include AP Stats, C++, AP Computer Science Principles, and AP Computer Science A. Becky has also taught pre-algebra, Algebra 1, Algebra 2, Visual Basic Programming as well. She has a bachelor's degree in mathematics education from Black Hills State University and a master's in mathematics education from Montana State University. So Becky, it's exciting to have you with us tonight.
It's great to be here tonight.
And John is a grandpa, splitting time between Hopac-Kong, New Jersey, and Lakewood Park, Florida. He taught mathematics and computer science at Teaneck, New Jersey High School for 35 years and is a longtime T-Cubed instructor. These days, John gets his kicks from learning Python, supporting TI's product development teams, writing new program curricula, and swinging in the hammock. And he wants to make sure that we point out to check out TI codes. So John, it's great to have you with us tonight.
It's an honor to still be here, Mike. Thank you.
At this point, Becky is going to discuss our agenda.
Well, tonight we're going to get started from the ground up. So we're going to show you how to get started and how to create documents. We're going to show you how Python has a lot of built-in menus and templates that are going to help make coding a lot easier. There's some formatting that's also going to make ease of coding. The keypad function's a little bit different in Python. There's some pre-built-in modules. And then we're going to round things up with how to manage your memory and how to transfer some files.
Awesome, Becky. Thanks so much. We'll be using the chat window to send general message tonight, but if you have any general questions for John or Becky, please use the Q&A window on the right side of your screen. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Without further ado, Becky, you have control. Feel free to share your screen.
All right, well, I'd like to start off tonight. John did mention to check out TI codes. So after you watch the webinar tonight, if you have not been to TI Code yet, there is a section on Python programming, and it's got a lot of great intro activities to help get you started. There's both the CE and the Nspire platform, and so it's a great place to kind of go once you've played around tonight with us to kind of dig in and start looking at different units and getting some ideas on how to build on your skills. So with that, I'm going to start out with the very first activity I did in Python with my students. It actually was not in a programming class. It was my AP Stats class. I showed up to class that day and the internet was out and I needed some dice. And I'm going to move that poll off my screen. I needed some dice and the internet was down. And so I'm like, what am I going to do with my statistics kids? Well, we all had Python enabled. So what we did is we are going to just go from the ground up. So from now on your TI-84 plus CE, when you hit program, you'll notice you now have two options. So if you coded in TI Basic is still there, but now you can go down to the Python app. And if you have other projects that are in there, notice I've got a ton of things that are saved. That's what they're going to look like. But with your students, you would just say, I want to start a new document. And I'm just going to call it Q for now for quadratics. So to notice for a name, just like with TI Basic, your name for your file can be up to 8 characters. It can be anything from A through Z. You can use numbers and the underscore key. To get to the underscore key, you just hit the second and the minus sign. So if you happen to be wanting that underscore key, that's how you get there. And with that, I'm just going to leave the types alone. We'll talk about that later on. So right now it is optional. So I'm going to go ahead and say, okay. All right. So for the rolling of the dice, I was going to ask my students to roll 2 dice and find the sum. And we were looking at summary statistics. So all you have to do, notice there are menus along the bottom. So everything is menu driven. You don't have to do a lot of typing unless you're going to have your variable names, because obviously those are probably not going to be pre-built in your menus. So the first thing you would do if you're going to do random dice is to go to the module keys. Whoops, wrong button back. I wanted to go to functions, and I'm going to move a window. From your function keys, random dice have to have a library import. And so I'm just going to use my arrow keys down, and I'm going to say from random import. And what that does is it opens up a whole bunch of commands for me. I go back to that function and over to the modules and the random key. You'll notice inside this random library, I have access to a function called random. I have access to something called uniform, which is going to pick them from a uniform distribution. I can have random integers. I can do choices. If you've done choices in Python, that's kind of fun if you have a sequence. But right now, I just needed a random integer. Rand_int is not a pre-built-in function for my students, so they had to do a quick import. If they're on the window and out of order like me, if they hit the random integer function, it's already built into pre-mode here, where if I need a variable, and I'm going to call it just my sum here. And so I'm just going to type in sum, S-U-M. Notice I didn't have to hit the insert key. It's already in insert mode for me, which is kind of nice. I must have hit the alpha key, which made my sum alpha locked up into a capital character. So again, for my statistics class, this is the very first thing I did with kids. They had no coding background experience at all, which is why I'm doing it with you guys to show you how easy it is to simulate rolling a pair of dice. So I needed a random integer from 1 to 6. And just like the students, oh my goodness, I typed an alpha character. Not a big deal, just arrow back, hit delete, hit the alpha, and it will take me out of alpha mode. Or the polling option will jump back on your screen and I'll get rid of the poll. Second alpha lock, there we go. Alpha is now gone. I want a random dice from 1 to 6, or if you wanted to do odd shaped dice, they could have gone 1 through 5, they could have gone 1 through 8. You decide what your dice is going to look like. And then I'm going to add on another random integer. Students could type the whole word randimp, but again, it's all about being menu driven. So I'm going to go hit the function button, go back to module, go to random, choose randint. I'm going to go from 1 to 6. And now I have a random dice. The only thing left for the students to do was print it to their screen. So to do a print function, I'm going to hit the menu option. It's not a module, so I'm going to pause here for a moment because I've done everything relatively quickly. I am going to slow down and walk you guys through a whole bunch of menu options. So this is where I'm going to pause for a second. If I was looking to print that dice to my screen, any ideas what menu option that print might be through?
While people are thinking and typing, I just want to jump in real quick. This is Becky going a little bit slower than she normally does. Becky is a fast talker. She might as well be maybe a New Yorker, I don't know. But this is being recorded. You automatically get a link with the recording in a couple of days in your email. And that's a great way to really follow along at your own pace. You can pause and rewind. So especially in this first part, I know Becky was planning on going fast and she will be slowing down. But just so you know, you will be getting a recording in your email in a couple of days.
All right, so notice that everybody who's typed in 100% correct, the IO. I believe on TI Basic it was an IO for input output. So I'm just going to use the arrow keys and arrow over to my input output. And I'm going to choose print. And then I'm just going to print the sum. I can either continue to use the keypad and type SUM, but there's this great little menu option that some of my students might find useful. I might find useful. If I hit the second button, so it's going to be my window option, I can actually now have my arrow keys activated, which will let me come in and hit an S with a nice little enter key, a U. And so for me, I have found this like life-saving because it's so much quicker for me to hit the arrow key sometimes than to try to hunt and peck on there. Yep, the windows are awesome for finding pre-built-in tools. And so now I'm just going to choose paste. So in 3 lines of code, I've imported a library that's going to let me have random features. I have a sum that's going to do random integers from 1 to 6, and then I'm going to print it. All that's left is to run it. My first sum is a 10. If I go back and I hit edit and I say run again, which notice this edit is right above my trace button, which is why I'm choosing the trace. Now I have a sum of 9. Okay, so this was really cool to do it once. But any idea how to make code, maybe have it display 3, 4, 5 at a time? Those of you who've coded before, what are we going to do? Great question. You do not have to seed it. So coders in the audience, what's the keyword that might let me repeat this action over and over and over again? Loops, you got it. And guess what? They're going to be inside a menu as well. So for students, right above the menu, they're going to hit the functions. Loops. Any idea where loops are? About controls. Okay. If you're not native to Python, I think if you've done coding before, or if you haven't done coding before, an if doesn't sound like a loop, but a for sounds like it's going to be a loop for me. So now I just get to decide how many times I want my loop to happen. So I'm going to say I want 5 dice rolls, or you could do 100 dice rolls. The only difference with Python that took me a little bit to get used to is notice these 2 little diamonds. Python needs everything indented for a loop. So what you have to do is come down and say, I want both of these actions to be part of the loop. So I'm going to just move my cursor to the next line. I'm going to go up to the menus, and I'm going to go, there's got to be a way to indent. And if you don't know where it's at, let's just go look. It's not a control. I don't see the word indent. It's not an operation, not a list, not a type, not an IO, not a module. Oh my goodness, maybe indent isn't an option. Or maybe it's not a function. Notice next to this little handy dandy keyboard that let me do my typing is a tools option. That tools option is where you're going to find the indent. And notice it has now moved everything in. It's nice. I can see the little diamond shape. For those of you who have coded in Python before, I've spent hours debugging kids' code trying to figure out this one was a tab and this one was like spaces where they thought they lined stuff up. These diamonds, I think, are going to be lifesavers in the classroom. I'll just go down to the next one. Notice I'm not even at the beginning of the line. I'm in the middle of it. Go back to tools. Notice there's also a copy and a paste feature in here. Those are kind of handy, as well as an undo clear. But then I'm just going to choose indent. And notice now I have everything inside my for loop. So if I hit run, now I have 5 dice rolled all at once. Lifesaver, my AP Stats kids, most of them had never written any code. None of them were in my coding class. And relatively quickly, my students could make this nice little dice thing that would let us roll dice over and over and over again. The key to notice is this indentation is awesome. But it will trip you up if they don't use it appropriately. So let's say they forgot to indent this last line right here. So I'm going to unindent that. Now when I run it, it will only give you your last line because it's now not part of the loop. So one thing to kind of watch with kids and really emphasize when you're doing Python is that indentation piece is key. Okay, so now as Mike said, I'm totally going to slow down. That's just my very first coding project, and I wanted to share with you guys how easy it is to do with kids. Like I said, day one in AP Stats, not day one, but day one I needed an app. We wrote it together. Okay, so now let's start a project from scratch. I'm going to hit the program button. I'm going to go to the Python app. And then I'm just going to say I want a new app. I don't know about you, but one of the typical ones that I found very useful with my Algebra 2 students was the quadratic formula app. Anybody else out there use the quadratic formula app with their students and have it help you find roots or decide whether or not they're imaginary or not? Yep, so those of you who've done it with BASIC, someone's already said they've done it with BASIC, it's going to look very similar. So I'm just going to call this quad. And I'm going to say, okay. So for the quadratic formula, what's the first thing you need to get from students if you're going to do the quadratic formula app? What are some of the inputs you might need? Yep, TI basic lingo, prompt A, B, and C, correct. So instead of prompt in Python, it's going to be the word input. So without further ado, let's just do a nice little A here. Whoops. Oh, I love the escape key. If something doesn't work, escape pops up if you went to the wrong menu. So if I go alpha A, and then I need to assign it a value. So this test feature right here is going to have a option to test it. The equals is if you're going to assign a value. The equals would be if you're going to have an if statement. I'm just going to use the equals value. Then I need to prompt, but the word is input, the value from the user. Python, when you input an information, it doesn't realize it wants to be numbers. So we actually have to tell it that we want either floats, so there could be decimals, or you want integers, and you're not going to allow decimal input. If they put a decimal, they're going to truncate it. So to do that, I'm going to hit the menu button. I'm going to go to my type, and you're going to have to decide with your students, are your A, B, and C values only going to be integers? Because if you choose integers, it will truncate and drop off a decimal if someone enters it, or if you want it to be a float value. So I'm going to go ahead and choose float from my type menu. And then I'm going to go back to my menu options with my functions. And I'm going to go to that same input output that we did for print. Only instead of doing print, I'm going to choose input. Okay. I could just say enter A, or I could just say A as a quick prompt. Depending on the amount of typing you want and how descriptive you want that input to be, it might be useful to use this little toolpad again and use your arrow keys to say something like enter A. Because inside here, there's even a nice little space on the top row. Or you could just use the keypad and type them in with your alpha lock going. Or I don't even have to use the arrow keys. If you're on your teacher software like I am, if I just hit the A button, it will actually put the A in there for me. And then I'm going to close it out in quotes. Okay, so then I'm going to go ahead and hit the paste option. I did something a little sneaky there. Notice I put it in quotes without telling you why. It's string. So if you're going to display something to the screen and you want it to be a bunch of characters, it's going to need to be inside either double or single quotes. Either one will work. I'm going to go ahead and just run that and see what it looks like. So it says enter A. It's going to let me enter it. There is no space whatsoever by the default method here, so they are going to be a little crammed. I hit enter. Nothing happens, but that's as far as we got. So I'm going to go back to edit. If you want a space before they enter the A value, you can actually just go add a space, which happens to be an alpha 0, or I could go back and hit that menu option. Now, as much as we all had fun typing that, you could retype all of that and go back in through the menus. But there was this great tool that I showed you. Anybody remember what the tool was that I kind of showed a few minutes ago? That might be helpful. Copy and paste, you got it. So I can either retype it, or I can hit the tools menu and I can copy the line, and then I can hit the tools menu and I can paste the line, and then I might as well go ahead and do that again. I don't think I have to recopy the line. I think I can just say paste it, yep, and it will repaste. And now all I have to do is go behind the A and say delete and change that to a B value. I don't know about you, that's way quicker than retyping and putting all that back in. If I was with my students at this point, I would probably have them run it and make sure that when I run my code, there aren't any errors. Because the biggest issue with my students, even though when I use the menus, it nicely put the parentheses inside the parentheses. Somebody might have accidentally deleted off one of the parentheses at the back end. And I think it's going to be a little bit easier to problem solve if you run it as you're going than if you wait till the very end. Okay, so it looks like a couple of you have done this before using TI Basic. What's the next part of my code? What do I need next? I need a formula for storing. Okay. What else am I going to need? I might need an import math statement. One more thing I might need is maybe an if statement. For quadratic formula, it's great to talk about if you have one root, if you have two roots, if you have three roots. So all of those things are right. Discriminant, you got it. We're going to use a discriminant. So I'm going to go up to the functions. I need an if statement. If statement. Well, functions doesn't have an if statements. Controls have an if. All right, using my discriminant, I'm going to have three options: 1, 2, or 0 real roots. So I'm going to come down and choose the if else. Notice for those of you who've coded, this is kind of interesting to get used to. If, it shorthands the else if. Okay, it's beautiful. It brings in a template, and I want you to notice the color changes. I now have three colors floating on the screen. I have the red color, which is going to be used for our math calculations. You're going to see more of this red pop up as we go. I have green for our string. And then I have the blue for the built-in functions. So I'm just going to type that discriminant right in. So I'm going to say if b squared, if b, and I want everybody to watch this. This is kind of cool. When I hit the squared button on my calculator, Python does not use the caret symbol for squared. It's a times. Use the caret symbol. It's going to do some bitwise operation, and that's kind of fun to go read about in your spare time. But you do need to know that the little caret symbol is not the same as the squaring function. Let's just see what happens if I hit. Notice if I hit the caret symbol, it also gives me the times. So that's going to help out with your students so you don't accidentally hit the caret symbol. So I'm going to say if b squared minus 4, and then you have to do a times a and a times c. If you put the a and the c together, it doesn't realize that those are two separate variables. So b squared minus 4ac is greater than. Greater than is going to be in my test, or it's also inside that handy dandy little alphabet key here. So you can either go to the alphabet key and notice there's a greater than symbol there, or you can hit second test and you're going to find, oops, wrong symbol, Beck, greater than key in there. So if you are greater than 0, for now, I'm just going to print that there are 2 real zeros. So you guys have already found the print statement that was under the function in the input output. And again, if I have a lot of typing, I kind of like this alphabet menu here. So I can say that there are, oh, there's no numbers in there. That's okay because I can type it. 2 real roots or zeros, whatever you want to call them. And then I'm going to close those parentheses. I'm going to paste that in there. And what's nice is then you can either retype all of that, or you can do that copy paste line and then just do a little editing, which I think sometimes is easier to just copy my line and then tell it to paste my line below. And then just change that to a 1. And then you could decide if you want to type the whole word 1 in there, or maybe you're okay with just putting the nice little number symbol there. Or I could put one double root if you wanted your students to put a double root there. I think that's what I have in my handout is a double root. And then last but not least, I can come down here and I can do another paste. Tools, paste my line below, and I can say that there are 2 imaginary roots. And for imaginary, I'm probably just going to go type it. Spelling might be nice. 2 imaginary roots. And then I'm going to just go ahead and run it. Oh, I have an invalid syntax. I love this built-in feature. It tells me exactly where my issue's at. I have an issue on line 7. I go back to editor. Notice up at the top, it tells me right now my cursor is on line 1. So if we arrow down to line 7. Oh, in my haste, what did I forget? Yep, somebody's right in the chat. I forgot the formula again. Okay, so I can either retype that. I don't think I want to copy and, well, I could copy and paste that and then do some deleting. Let's just see. I don't want to do that. I'm going to go ahead and type it. So b squared minus 4 times a times c. Oh, okay. If you hit the equals, it's going to assign the value 0 to that expression, which is kind of funky and it doesn't really work out. Inside your if statements, you actually have to use the equals equals. And that's going to check to see if they're equivalent. And so that's actually what I tell my students is this is the equivalent. Are they equivalent for their programming values? Equals and equivalent are the same verbiage, but that's kind of how I separate them in my head a little bit. And now if I run it, 1, 2, 3, has 2 imaginary roots. Last but not least, if you wanted to make this into a loop, you could do exactly what I did with the DICE program. You could come up to the menu and add yourself a nice little for statement. And maybe you want this to happen 5 times. And now you just have to go indent everything that's in there. So I go to my tools and I go to indent. I go to the next line and I go indent. Indent all the way down. Those diamonds are amazing because now I, as the teacher or as the student, can do a quick check. Everything is 2 diamonds in for the for statement, so it's got a tab. And then my if statement actually is 4 sections in there. All right. So I knew that was going to take us a little bit longer, so I have a couple of predefined quadratic ones to show you. If you've done this with your students and they have the skeleton program, it's really easy to do a different version of the quadratic formula. I'm going to hit my files button for a second and go grab one of my pre-made files, quad 2, and go to the editor. And you'll notice someone did say we might need a math import. If I wanted to do the square root function, I would need to import the math library, but now I have access to calculating my root values. And then if I keep arrowing down, there's my roots. And what I like is you can actually have complex values very easily printed in here. For the complex values, you put the real part first and then the imaginary part second. And this is actually in a handout that's going to be attached to the webinar here that will give you the code for this if you wanted to write this on your own. But now that imaginary problem that I had from before will actually show my imaginary root values. If I rerun it and I did, go ahead.
Notice the J.
Oh, good call on the J. That is something to point out to students. There's a lot of things you can do with the quadratic formula. For those of you who have done Python before, you could even kick this up another notch. And if you like functions, you could actually have them just type in and make it a function and not have to deal with the prompts. And you could say that the values for A are 1, 2, 3. close my values, and it'll print those out. So those will be in a handout that's provided at the end if you want to do some functions. So there's a lot of different ways you could do the quadratic formula with your students. All right, so with that, I'm going to pass it over to John, and he is going to continue our Python exploration today. I can pass it to you, John. I think you have it.
Got it. And where's my software? There we go. Okay, Python is a big change for this TI-84 plus CE Python edition. When you're running Python, the entire calculator is devoted to Python only. There's nothing else you can do on here. I'm going to continue for a second with the Becky's Dice program. So this prints out 100 sums of 2 dice. And actually, when I'm working on the computer software here, I got to give you a warning. I'm always tempted to click on these, what look like buttons on the bottom of the calculator screen, when I should be pressing the buttons up on the calculator keypad itself. So as in my own personal view, I prefer working in the calculator when it looks like this, so that I'm not tempted to press these buttons on the screen. I'm tempted to press the function keys below it. And the function keys, y equals and window and zoom and trace and graph, don't do anything anymore because you're not using the calculator as a calculator. You're using it as a Python programming environment. A lot of other keys are different. Like the math key brings up the math module instead of that math menu that you're accustomed to when using the calculator. The apps key doesn't do anything. The program key doesn't do anything anymore. The vars key doesn't do anything. All you're dedicated to is the Python environment. On the TI's website, there's an e-guide for Python for the TI-84 plus CE Python edition. And one of the components of that is the Python programming environment. And it explains how the whole keypad is remapped just for the Python experience. So when you're working with Python, you can't do anything with a calculator as a calculator anymore. You're just writing Python programs. I'll hit escape here. There's this editor, and that lets you write the code. And then when you run the program, you're working in the shell. In the shell, Python shell is the place where Python programs are executed. That every Python environment that you work in has both an editor and a shell. The editor is for writing, the shell is for running. And the third component of the Python experience in the 84 is the file manager. When you hit the files button or the graph key on the keypad, then this is the list of files that are currently available in your editor. It's not all of the files I have for Python in my calculator, but more about that later. Let me go back to the editor. I want Dice EE again, right? I'm going to switch my screen back to full screen right now because it's easier for you to see. I'm going to edit this program, switch back to the big screen. The big screen. The big screen. Where's the rest of the screen? You can't see my screen, can you? Unless it's over here. There it is. I didn't expect that to happen. So Becky's Dice program is embedded in here. The for loop, the sum evaluation, and the print statement are all part of her code. What I've done in this program is added some extra stuff so that I can store that list of sums into the calculator end of it. Right now I'm working in the Python world. On the other side of the world is the calculator itself. Lists are designated by square brackets. in the Python world. And this first statement creates an empty list, L equals, and then the square brackets here. The square brackets are on that alpha key. Down below, in this section, I'm going to hit escape. The square brackets are also on the list key. First item on the list menu is this list. This list is now the Python functions that are applicable to lists, not the TI-84 list menu anymore. And I'm going to hit escape to get out of that. And the square brackets are also on the keypad. If you hit second multiplication key and second subtraction key, you get the left bracket and the right bracket. So there are lots of different places to get these square brackets from. This defines the empty list. The statement after the print statement, L.append, adds an element to the list L. And the value of the variable sum is appended to the list L. Finally, and this is the big thing, and this is why TI system is important here, this store list command stores the list L into the TI-84 list L1. I should have taken away this capital L here because I'm going to repeat this command for you in a moment. I'm going to delete that character L. So this stores the list L into the list L1, the built-in list L1 in the calculator. If that capital L were there, it would create a named list L1, which is different from the built-in list L sub 1. TI system. I'm going to press the functions key, go over to modules, and under the module menu, there are several different modules. Math module, Becky used in the quadratic formula program. The random module, Becky used in the DICE program. The time module, none of us have used yet, but it's got commands like sleep, which is like a wait command for the Python world. And then there are 4 that are called TI modules. TI system is the one I'm using here to store a list into the 84 world. TI plotlib, I'll show a demo of in a few minutes. And hub and rover, if I have time, I'll show you 2 short, quick demos of those as well. These modules are TI created, and they're included in this package. And so you don't have to do anything except get your TI-84 plus CE Python edition, and all of this stuff will be included in there. The first 3, math, random, and time, are Python standard modules. They come included with all Python implementations in the world. But they're included here because they're valuable ones for us in the classroom teaching this stuff to high school students and middle school students. On the TI system module, there's the import statement. In order to be able to use these functions that you see on this list, you have to import this module into your code. Python is very lightweight to begin with, but it uses this modular system of being able to add value to your program by importing other utilities from other modules. The store list command is the item number 3 on this list. The name is the name of the TI-84 list that you want to use, and it can be a number from 1 to 6, or it can be a named list. And the var is the name of the variable that you're using in your Python program. So it's give you some of these tooltips. The placeholders are just descriptive in here when you look at this menu. But when you choose this command, and I'm not sure my cursor is in the right place in my code, so we'll worry about that in a moment. If I choose this command by pressing enter, then it pastes this command store list into your code wherever your cursor happened to be at the time, which is probably not in the right place right now. So I've got to delete that. There is no undo command in here. So I just use the delete key. The delete key is now a backspace key, by the way. It's not a delete key like it is in the rest of the TI-84 world, and it only acts as a backspace key. So this store list command will store the list into the TI-84 in list L1. So if I press run again, which is the trace key up there. It generates the 100 numbers. And it stores the list over in the 84. So I'm going to quit the Python world. Okay. And look at my stat editor. And the list L1 contains the numbers that were displayed from the Python program. I can graph this stuff. Let's see what happens if I press the graph key. There we go. I already had it set up. Sorry, folks. This is to save time. But you can set up a stat plot. Plot 1 is a histogram of L1. And when I press the graph key, it just plots that data. Notice that the highest one is in the middle. Isn't that a surprise? So there's a way of getting data from the Python world over into the TI-84 world and working with that data in your code. On the TI bulletin board, Becky has a much better implementation of this simulation. It doesn't have to generate 100 numbers. It can generate 1,000 numbers or 5,000 numbers or 20,000 numbers. The nice thing about Python is that there is no upper limit to the number of the size of numbers. Integers have no upper bound. But in the TI world, I'm going to go back to the DICE program again. The way this program is written is not the most efficient because it's storing each sum in the list. So there's going to be 100 values in this list. If I try to go to 200 values instead of 100, delete this and make it a 2, and run the program again. Gives me 200 numbers. Should have done 101. And I get this error message. List length is greater than 100. In line 10, I have an error message, and it's a runtime error. It's not a syntax error. So it let the program run until it encountered this error on line 10. The list length is greater than 100. To see line 10, go back to the editor, and it's this store list command that's causing the error. Store list only lets you store a list of 100 elements or less from the 84 to the Python or from the Python to the 84. So with Becky's method, if you look at the TI bulletin board, Becky has a blog in there about coding Python on the CE. And she shows a better method for storing these sums more efficiently so that you can do more than 200 or 100 trials. But you'll have to read the bulletin board for that. I'll leave that as a surprise. One of my favorite tools on the TI system menu is the while not escape command. I have a demo of that in here called PyDarts. Where's PyDarts? There we go. So when I run this program, I'm not going to show you the code yet. I'll select run from the menu. If you just press enter on one of these files, it automatically runs it. Or you can press the run function key. And this is what's happening. It's tossing darts at a dartboard, which is a 2x2 dartboard in the center of the screen. And the red dots are the hits. Those are the dots that are inside the circle that's inscribed in the square. I didn't have time to create the square or the circle. The black dots are outside the circle, and the red dots are inside the circle. So the number of dots inside the circle over the number of dots total is going to be an approximation of pi over 4. Figure out the math because the areas have that ratio. So when I multiply that ratio by 4, we get an approximation for pi. To stop this program from running is what I'm going to emphasize here, and that's by pressing the clear key. And the program ends. Now the code. This uses a utility called the TI-Plotlib. Import TI-Plotlib as PLT is another way of doing an import command, but any of the functions that are in that library must be preceded by the name PLT. This is a convention that carries over from the real Python world and a utility called matplotlib in the Python development world. So this clears the screen, this sets up a window, this turns on the axes. This recalls the list from the 84, if there is one. Otherwise, it starts out from scratch. So if that list doesn't exist, it starts out with zeros as the number of hits and the number of totals. And here's the while not escape loop. So it adds 1 to the total number of darts, picks a random number for the next dart. X and Y are going to be from -1 to 1 in decimal form, not integer form. It works like randint, lower bound and upper bound, but instead of choosing integers, it chooses decimals or real numbers, if you want to call it that. The color is set up. If x squared plus y squared is less than 1, then it adds it to a hit variable, changes the color to red. Notice that we have 255, 255, 255, 255 to the third possible colors in the Python world. That's a heck of a lot better than the 16 colors on the other side of the TI-84, which only allows red, black, orange, green, and blue and stuff like that. We have 16 million colors to choose from. And this last statement here puts the dots on the screen, plt.plot. So this PLT, the plot library, is used for plotting points. The while not escape lets me run this program until I press the escape key. But there is no escape key on the keyboard, so we use the clear key instead. That represents the escape key. Okay, enough about coding. Let me talk more about how this Python world interacts with your calculator, because this calculator is phenomenally powerful, but it's also limited in memory. So not all your Python programs are going to fit in your calculator. I'm going to quit. Okay. Press the mem key. Your Python files, your Python programs are stored as app variables. So when we go into the memory management tool and go up to app vars, the ones that have a PY on the right-hand side are your Python files. So you'll see PyDarts in here somewhere. But the ones that have an asterisk next to them on the left-hand side are stored in archive memory, and the ones that don't have the asterisk are in RAM. The ones that are in RAM show up in Python in the file manager. The ones that are in archive do not. And so the ICE program is in RAM that I used before, but there are a lot of other files in here that I don't see when I'm using the Python file manager, because all these files are in archive, because I have more files on my calculator than can fit in the Python editor, Python file manager. So you're limited to 100 files in the Python editor or 50K of RAM. And I find that I'm running out of RAM more often than I'm running out of file space. So all of these other files that are in here are archived. So if you find yourself running out of memory, just archive some of your Python files. And to archive a file, you just press the Enter key in the file manager to move it from RAM to archive. Press Enter again, and it goes from archive to RAM. And you'll notice the numbers changing on the top of the screen as you do that. So this archive feature is still very powerful to use, even when you're coding in Python, because your number of programs and the amount of space that's available for programs is limited. I'm going to quit this memory manager and talk for a minute about transferring files. Both TI Connect and TI Smart View have this Explorer view that lets me see what files are stored in my calculator and allows me to transfer them between the calculator and the computer. What I like to do in this Explorer is click on the name column and then the type column, and then look for appvar Python down here, and all my Python files are in alphabetical order. If I drag a file from the Explorer to the desktop, I get an 8xv file. That's an 84 app variable. But if I right-click the file and choose Send to Computer, I can change it from an app.var Python to just a plain old Python file. And if those of you who are using Python will be jumping in your seats about this, save it. And now on my desktop, I have a py file instead of an 8xv file. This py file is readable by any text editor because it's a plain text file. So you can open it up with Word or Notepad or TextEdit on the Mac or any other program that can read text files. But if you have a Python installation on your computer, you can open it up in your Python world. And this is my Python editor. I click Run and Run Module. And without any modification whatsoever, I took a program from the TI-84 Python world and ran it right on my desktop in the separate Python environment in here, because this file doesn't use any special TI modules. All it uses is the random module, which is part of Python everywhere. So it gives us more power to take work from the 84 world and use it in the rest of the world. As part of the supplemental documents that are going to be attached to this webinar once we're done here, there's going to be a PDF file of sample programs, but they're all screenshots of the TI-Nspire programs. Trust me, all of those programs written as is on the Nspire will also work on the 84 with the Python edition. So you can import those programs into the 84. You can copy and paste them from an Nspire into your editor on the computer, and then transfer them into the 84. The Python file will go in directly. This Python file will drop onto the 84, and it converts it to an 8xv file. So this will send it to the file, but the file is already there. Would you like to replace it? Yes. And I've just taken a py file from my computer and put it into the 84. How are we doing on time?
About 3 minutes, John.
All right. I was going to demo the hub and the rover, but I've got to give some time to Mike for showing off some of the final stuff and final notes for the rest of the session. Thanks for your time, and you got my email address in there somewhere. And make sure you watch the recording and play it back slowly because we go too fast. Mike, I'm going to pass it on to you. Assign to Michael. There you go. And yes.
Awesome. Thanks so much, John and Becky. I did remember to unmute, so that was a good first step for me. A lot of people were having some great conversations in the chat window while this was going on, so I encourage them and everyone else to continue that conversation on any of those major social media platforms. As we wrap things up tonight, if you have any last-minute questions for John or Becky, please try to get those asked. I know they will do their best to get those questions answered. To receive a certificate of attendance, go ahead and click the link that just appeared in the chat window. Also listed is a link for the documents, and I really want to highlight, I know it was mentioned tonight, but one of the documents in that documents link is something called the Link TE Guide. And I think both John and Becky would probably agree that there's lots of great things in the documents folder that we're giving you, but that is a nice shortcut to the eGuide, which is really helpful if you are programming in Python. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. And if for any reason those links aren't working tonight, just hang tight. You'll automatically get a follow-up email within a couple of days. And like John said, That email contains a link to the recording, and it's really great to watch us with the recording. That way you can go at your own pace and pause and rewind. Also will be links to the certificate and the documents. If you need to get in touch with us after the webinar, feel free to give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. We'd love to hear from you. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online events. So let us know what you thought tonight. If there's other things that you'd like to see or more things like this, feel free to let us know. It really does help us plan webinars in the future. Lastly, a huge thanks to Becky and John. I know they put a lot of time into tonight's webinar, and I really want to thank them for that time and their expertise.
A lot of fun.
And hats off to Mike, because he's been doing this for years, right? How many years has it been?
This is my 9th year.
9th year of doing this every Tuesday night, right?
So every Tuesday. Yep.
Thank you, Mike.
No problem. Thanks so much for you guys, again, for putting everything together. And thanks so much for everyone for being on tonight. I hope the school year, if you started, is going well. And if you're about to start like me, good luck and enjoy your last couple of days of summer. Thanks so much. And we hope to see, yes. Thanks so much. And we hope to see everyone back online next week. Have a great night, everyone.